Alright, you guys, this video is for Honors Algebra 2. It is 7-5, which is properties of logarithms. If you recall from the 7-4 video, I said that it was a pretty simple lesson where we had two types of problems, basically, where you had a single log and then you would switch it to exponential form. And when you had two logs, you would cancel them out and just simplify whatever expressions were left over. That's essentially what we're going to do here, except today we got to take a couple of properties before we can do that. So everything today is going to go back to those types of problems, but there's a couple of properties we got to learn first before we can do the problems that we did the other day. So that's what this lesson gets new stuff into. So the first slide explains those properties a little bit. The first one's product property. If you look here, a little tidbit here, because logarithms are exponents, properties of logs are derived from the properties of exponents, so you're going to see a lot of similarities here. The first similarity is this. If you have two logs, there's my finger, there it is. Come on. So if you look at these two logs, and you see how they have the same base, so you have log base x of a plus log base x of b, you can rewrite that as log base x, so the same base, of a times b. So basically you can rewrite sums of logarithms as one logarithm with a multiplication. So that's what today's going to be. We're going to have two logs on the left side or two logs on the right side, and you're going to use one of these properties that we're going to do to get it down to being one log, so that way you can cancel it or switch it just like we did the other day. So the first property is the product property of logarithms, where you have a sum of two logs with the same base. You can rewrite as one log with a product of those two quantities. So for example, down here, you'll have log base 2 of 5 plus log base 2 of 6. You can rewrite that as log base 2 of 5 times 6, or 30. The second one is the quotient property, which is very similar. If you have subtraction of two logs to the same bases, you can rewrite it as a fraction. Okay, so same kind of concepts here. You have log base x of a minus log base x of b, equals log base x of a over b. Notice the first one's on top, second one's on bottom. Okay, so pretty similar to your product property. The little bit of an oddball is the power property of logarithms, and it kind of comes over here. So if you have log base b of m to the p power, okay, so the quantity you're taking the log of, it has an exponent on it, which is that p. If my finger would move, I don't know why it's not moving, but it's stuck there. So basically what it allows you to do, if you look to the right of that, there it goes. If you look to the right, you'll see that you can bring the exponent in front of the entire log. Now we're back. So you can rewrite this guy and bring this exponent down in front. So p log base b of m. So these are basically going to be your roadmaps, and here's an example of that also. These are going to be your roadmaps to get these problems down to what they were last time, which allows you to take cancel the logs out or do an exponential switch. Okay, so these properties let you get them simplified down to the 7.4's properties, which allows you to solve the problems. So the first example here, we have 2 times log base of 7 equals log base of 27 plus log base of 3. So the first thing I would do is I would move this 2, since it's here, you can't really divide it by it, okay, because this is all ugly. Divide by it, move this up to the exponent, so make it log base 7 of x squared equals log base 7 of 27 times 3. And combine these two sums, this sum with a multiplication, so 27 times 3 here. Alright, and then just to make it clean and nice, we're going to do a log base 7 of x squared equals log base 7 of 81. So you're applying your properties to get it to look like a 7.4 problem where you just have 2 logs on either side. From there you can cancel the logs out, which leaves you with x squared equals 81. From there you can simplify it or solve it, like you would any other type of equation. So since it's got a square root or square power, we're going to take a square root of both sides. Now we know that once you take the square root, you have x equals the plus or minus 9. Since you took the square root, you put in plus or minus. So right now, your answers are x equals plus or minus 9. You go back through and check them. When you plug the negative one in right here, you throw it out. So your only solution is x equals 9. Sorry about my voice today, guys. A little raspy. Okay, so that's one example. That's your basic example where you get logs on both sides. It's the only one I'm going to show like that. The rest of them are going to be switches. So just combine your logs. You'll have more of these in your homework, but this isn't too bad of an example. The ones where you have to switch are a little more complicated. So I want to trying to shorten the videos, trying to get them to not take, 30 minutes each time. So this will be the only example of that I show, where you have logs on both sides and you just cancel them out. The rest of them are going to be ones kind of like this, where you have a log on one side. So that's what I always look at first. Do I have logs on both, or do I have logs on one? Okay, and if you look at the equals, here it is. So you have logs on the left side of it. Since it's a plus, you're going to combine them with a multiplication. So you have log base 6 of x times x minus 9 equals 2. Okay, obviously showing all my steps here. If you want to go ahead and multiply these together from the start, that's fine with me. So log base 6 of the quantity x squared minus 9x. I would leave that as a quantity though. Okay, definitely. That way whenever you do your log to exponential switching, you bring the whole quantity to the right side. That's what's most important here. This whole quantity is what moves over. So 6 squared, when you do your switch, equals x squared minus 9x. Okay, so that's how you do it. Whenever you have a log on one side, you get down to a single log like this, and then you distribute that x through from here to here, and then do an exponential switch. And from there, you solve it like a normal quadratic. So skipping a step here. So x squared minus 9x. 6 squared is 36. I'm going to subtract it over here to make it negative, and then I flip the whole entire equation, so my zero's on the right. So minus 36 equals 0. And then obviously you have a bunch of different ways you can solve this. So I'm going to do the quickest, which is factor, which gives you x minus 12, x plus 3 equals 0. Split them up, you get x equals 12, and x equals negative 3. You go back, you check them, negative 3 when you plug it in right here, you toss it out, so your only answer is going to be just 12. Alright, next one is very similar. I'm going to go ahead and let you guys do this one. You have log base 6 of x plus log base 6 of the quantity x plus 5 equals 2. Let's fix that last circle there. Okay, so hopefully you worked this out. You got 4 as your only solution. Hopefully negative 9 showed up, but you toss it out because when you plug it in. Right there. Alright, so that's kind of basically how these are going to work. Got 2 more examples for this video. The first one, I got a question set up here. I'm going to ask you something about the equation. So I'm going to show this one to you, and then go ahead and answer the question I have for you right here. Okay, so the only major difference with this problem is if you see you have the subtraction here. So you just be careful. That's the main reason why I wanted to ask you guys a question. I just want to make you stop and look at it so that way you know differently. So this one you're going to make a fraction instead of just multiplying. So some people get in a rush. They want to just knock these out because these ain't bad, and then they accidentally multiply where they should have divided. So be careful with this. So you have x plus 1 all over 10 equals 1. Okay, so now the whole quantity is of the fraction is what you're taking the log of. You have it to a single log, so we're going to switch it. So we got 4 to the first equals x plus 1 all over 10. And then from there, you're going to cross multiply both sides by 10, however you want to say it. So you get 40 equals x plus 1. We're going to subtract 1 from both sides, and x equals 39. Okay, so just don't get in too big a hurry, where you accidentally mistake a minus for a plus or something like that. Alright, the last problem is a word problem. It's a pretty good problem. I really like this one. You have the pH of a substance is defined as the concentration of hydrogen ions, which is H, in moles. It's given by the following formula: P of 8 pH equals log base 10 of 1 over H. Find the amount of hydrogen in a liter of acid rain that has a pH of 4.2. So we want to find the amount of hydrogen, which is represented by H. And it tells us that the pH of the substance of the acid rain is 4.2. So we're going to go ahead and, back up one time. There we go. We're going to go plug in 4.2 for pH, since we know that, equals log base 10 of 1 over H. Okay, so from here we got to go the other way. And this one's got a little trick to it, so I'm going to work this one out fully for you guys, so you guys recognize when you're trying to solve for variables and work with logarithms a little bit. So since this is a division, we're going to split this up and go the other way with what we've been doing. We're going to make this a subtraction. So we got 4.2 equals log base 10 of 1 minus log base 10 of H. Alright, now from there, I'm going to teach this to you guys. Log base 10 of 1, okay, and this is going to come up a lot in the next video, in the next two videos really. This is just a number, okay? Log base 10 of 1 is a number, if you notice that. So you can subtract that number to the other side, because we're trying to solve for this H right here. So we're going to subtract log base 10 of 1. Which makes equals negative log base 10 of H. Alright. Now the second trick to this is the fact that log base 10 of 1 is just 0. Okay, so this guy is just 0, so I'm gonna, to save me room, I'm just gonna go ahead and erase that and move my 4.2. Well, where'd it go? Well, I guess let's just erase the whole thing. There we go. And move it to the other side. Alright. Okay, this step's a little involved, so listen up. I'm going to multiply both sides by negative, because I can't do a switch with a negative log. And I'm going to move my log to the left-hand side. So I'm going to multiply by negative 1 on both sides and flip the way I have the equation wrote. So I have log base 10 of H equals a negative 4.2. And from there, hopefully it's coming obvious what you got to do next. You got to switch it. So you get 10 to negative 4.2 equals H, and then evaluate that in the calculator, which is going to end up being about 0.00063. Okay, so just so you guys have seen one word problem with this, word problems are going to come back in a few sections at the end of 7-7. So, but as far as this lesson goes, folks, that's the end. Hope it was a good one. Your assignment for this guy is going to be page, let's see, 4, not 3, 489, 36 through 49.